Hi everyone. So this is some harder problems that you would maybe see different levels of physics, but definitely in a college level. And I think if we want to have a deeper understanding of what's happening when we talk about electric charges and electric fields and electric force and all that, then we should actually do some calculations that are represented by actual numbers. So let me zoom in here a little bit if I can, and we'll do a problem. All right, so we have a couple of particles, and we have particle A has a charge of 2 times 10 to the negative 5 coulombs, and particle B has a charge of negative 12 microcoulombs. All right, and they're 8 centimeters apart. We want to draw a model of the two charged particles and then calculate the force of the particles on each other, or the force of A on B. All right, so let's draw a model of this. I don't know, so we have A and we have B, and they're 8 centimeters apart, so this is 8 centimeters. All right, and A is positively charged and B is negatively charged. All right, and we want to know the force of A on B. All right, so we want to know what is the attractive force that's happening in this direction. Like how much is this charge being attracted to this charge? Okay, so that's all our model really has to be. Now, for the actual calculations, this is where a previous video on scientific notation would be really important. Particle A, and actually one thing that I'll start writing out is just some variables that I also have always encouraged you to do. So charge 1, or Q1, is 2 times 10 to the negative 5. Q2 is not in scientific notation, but I think we should put it in scientific notation. All right, we have negative 12.0 microcoulombs. All right, now if we want to put that into scientific notation, right, we would have to understand that micro means 1 million, right, or 1 millionth. So we're going to take our 12 and pretty much divide it by a million. All right, and if you put that into scientific notation, you would get something that looks like this. You would get negative 1.2 times 10 to the negative 5. Okay. All right, a few other things that we know. We know the distance between the two objects. So sometimes we write that as R. All right, we know that's 8 centimeters. Again, we want this in meters. So we could do a few things. We could put this just as 0.08 meters. Or if we want to keep it in scientific notation, we can make it 8 times 10 to the negative 2 meters. All right. And then our equation here looks like this. We have, I'll put it over here, we have the force between two charged objects is K, a constant, Q1, Q2 divided by R squared. All right, so let's plug in some of these numbers. All right, so K is 9 times 10 to the ninth. That's just the constant that we have for Coulomb's constant. Q1 is 2 times 10 to the negative fifth. Q2 is negative 1.2 times 10 to the negative fifth. And all of that divided by R squared. Right, so R squared is really going to be 0.8 squared. All right, and you could actually put a lot of this into the calculator. Actually, let's just do our exponent in our denominator first. Let's handle that first. So this is actually going to be 0.0064. Okay, and now from here, you can actually put all of these things into the calculator. We might want to use parentheses to make sure that we're clear. The calculator should give us an accurate number here. All right, so let's see. 9 to the ninth times 2 e to the negative fifth times, tricky, 1.2, again, e to the negative fifth. A few negatives in there kind of throwing us off. All right, and then let's see, we need to do this. Divided by, that might not work. Let me see. This might not work. Let's see what happens. Actually, it did. Perfect. Okay, so it looks like it did all of our exponents first, and then it did the division last, which is the usual order of operations. So we get this final number of negative 337.5, right? And so that is the force that these charges feel. Now, if you remember anything about force, that's actually a pretty strong force. If you remember that force is measured in newtons, right? And so that's what we would put down for our final answer. So our force is negative 337.5 newtons. So if you imagine the force that's acting on this object, right, it's being pulled this way towards the positive, right? And this force, again, it depends on how close the objects are, and it depends on how much charge is on the objects. As this number gets bigger, the force will get weaker. If the charges get bigger, then the force gets stronger. But that's just a way to kind of do these calculations. So let me just kind of zoom out a little bit here so you guys can kind of see the full picture here. Again, if you did not watch my scientific notation video, please check that out. If you didn't really understand what I was doing on the calculator, check out my scientific notation video. But that's pretty much it. I mean, multiplying these numbers actually isn't that hard, especially when you're using a calculator. One thing that a lot of students make a mistake on is forgetting to do this squared, right? It's r squared. So that's what we did first. We did our 0.8 squared, and that gave us this number of 0.0064. All right, I hope this was useful. I hope you tried these problems. There's a few more problems on this handout, but I hope you use this as a guide.